Mercury, the solar system's first and smallest planet, but don't underestimate it. This is the Sun, and this is Mercury. I meant it when I said small. Mercury has a radius of 2,440 kilometers. That's 1/3 the size of Earth. Think of it this way. If Earth was a nickel, Mercury would be a blueberry. Mercury is also the second densest planet, beat only by Earth. Much of this density comes from the planet's metallic, mostly iron, core, which makes up 85% of the planet's overall radius, with a radius of 2,074 kilometers. But we'll get to the core later. Mercury is also an oblate, meaning that it's flatter at its poles, with a polar radius 1.65 kilometers less than that of the equator. But let's rewind a moment to this initial image of Mercury and the Sun. From Earth, Mercury appears incredibly close to the Sun. Really, Mercury is 58 million kilometers from the Sun, which is only 40% of the distance between Earth and the Sun. This means that Mercury has a shorter year than we do, by about 277 days. Interestingly though, Mercury's distance from the Sun is not constant. This is because Mercury travels the Sun in an eccentric orbit. It's egg-shaped. It's actually the most eccentric orbit in our solar system. The changing distance also has to do with Mercury's perihelion advance, meaning that the orbit does not retrace the same path each time. So while the orbit might look like this once, the next go-round it might look like this, or this. You'll notice how slow Mercury's rotation is in comparison with its orbit. One day on Mercury is equal to 59 Earth days. What makes Mercury unique is its 3-2 spin-orbit resonance, which means it rotates 3 times for every 2 orbits, which is super rare. The spin rate likely evolved from Mercury orbiting with an initial retrograde rotation, then was captured into a synchronous rotation with the Sun, meaning that Mercury used to rotate in the opposite direction of its orbit. However, the tidal forces of the Sun slowed Mercury's rotations until their rotations were synchronized, similar to the theory of the Moon-Earth connection. Mercury also has a unique tilt compared to the other planets, only 2 degrees. For comparison, this is Earth on its axis, with a tilt of 23.5 degrees. And with its small tilt, Mercury stands straighter than any other planet in the solar system. Because Mercury has such a small tilt, seasons don't really exist, as the Sun hits both hemispheres evenly. You'll notice, though, that while one side is hit with sunlight, the other side is left in the dark. This means that half the planet is extremely hot, while the other half is extremely cold. The temperatures can get as high as 430 degrees Celsius and as low as negative 180 degrees Celsius. This also has to do with the fact that unlike Earth, Mercury doesn't have an atmosphere to regulate temperature. It's basically naked. This is because the planet is too small for a strong gravity. Rather, Mercury has a thin exosphere made up of mostly oxygen, sodium, hydrogen, helium, and potassium, created by solar winds blasting particles off of Mercury's surface. This also has an impact on Mercury's magnetic field. But first, let's loop back to the planet's core.
Mercury's surface area is 28.88 million miles squared, which in proportion to the other planets is relatively small. Despite Mercury being the closest the planets has done, it is not the hottest, it is the second hottest planet. It is a terrestrial planet having 3 main layers. It has a core, a mantle, and a crust. Mercury's crust has no tectonic plates, and its iron core is enormous, making up 85% of the planet's radius, while Earth's inner and outer core account for about 55%. Because of the core's unusual size, it influences Mercury's overall size, causing it to shrink. The iron core has slowly cooled and contracted for about 4.5 billion years. By doing this, it pulled the surface inward and thus has reduced the planet's size to between 1 to 7 kilometers. The Messenger spacecraft orbited Mercury for about 4 years. Amongst its accomplishments were the mission determined Mercury's surface composition, revealed its geological history, discovered details about its internal magnetic field, and verified its polar deposits are dominantly water and ice. Mercury has no satellites and has only one NASA spacecraft, and that was the Mariner 10 in 1974 and 75. It was programmed to fly by the planet 3 times to take images of its heavily cratered surface. Mercury's magnetic field is distorted by the solar wind, which compresses the magnetic field on the day side and stretches it out to form a long tail on the night side. Interaction between the solar wind and the planetary field creates the bow shock and magnetopause boundaries, as well as features noted in this figure. In this display, 2 representative messenger orbits are shown in green. When the spacecraft is closest to the planet at night, the orbit looks like the representation of the solid green ellipse. 1/2 Mercury year later, the spacecraft is closest to the planet during the daytime, and the orbit takes the form of the dashed green ellipse. The messenger orbit carries the spacecraft across the magnetospheric boundaries and through each region of Mercury's magnetic field. Messenger scientists are trying to extract telltale signatures that indicate how Mercury's magnetic field would look without the solar wind. Mercury is shaped by its volcanic activity. The volcanic eruptions are more substantial than the ones on Earth, flooding the area much like a swollen river, drowning about 60% of an area as large as the United States. NASA researchers plan to use more data from the Messenger to compare the chemical composition of these volcanic floodplains with that of the highlands, in order to better understand Mercury's interior and exterior composition. Most of Mercury's surface would appear grayish-brown, and resembles the Earth's moon with its scarred many impact craters resulting from collisions with meteoroids and comets. Very large impact basins, including the Calris, which was 960 miles in diameter, and the Rachmaninoff, which was 190 miles in diameter, were created by asteroid impacts on the planet's surface early in the solar system's history. While there are large areas of swollen, smooth terrain, also cliffs some hundreds of miles long and soaring up to a mile high. They rose as the planet's interior cooled and contracted over the billions of years since Mercury has formed.
And that's Mercury. The smallest planet has a lot going on. Thank you for watching our video. We hope that you enjoyed and you learned a lot.